All right, today we're going to look at 2.3, which is quadrilaterals, and then we will go to 2.4, which is circles. Okay, so we have different kinds of quadrilaterals. Quadrilateral means four-sided figure. We have a parallelogram, which has two pairs of parallel sides, and its area formula is area is base times height. A rhombus is a special kind of parallelogram. All sides are the same length. Area is still base times height. A rectangle is a parallelogram with perpendicular sides, which of course forces it to have right angles. Its area is length times width, or still base times height. A square is a rectangle with four equal sides. Its area is a side squared. And then we have a trapezoid. A trapezoid has two parallel sides and two that aren't. And its area is 1/2 times h times base 1 plus base 2. And the way, what's really happening here, this is one that students have trouble remembering. Really what you have is, if you draw something like this, you've got two triangles. So you have 1/2 HB1, that's giving you the area of this triangle, and 1/2 HB2 is giving you the area of that triangle. So if you remember the formula for area of a triangle, this one's most like the triangle, except you have base 1 plus base 2, because you're dealing with two triangles. All right. The perimeter of a quadrilateral, you just add all the sides. Same as a triangle. All right, find the areas of the following quadrilaterals. Round to three significant digits. Well, we have a parallelogram here, so its area is the base, which is 4.85, times the height, 3.16. Let's grab a calculator here. 4.85 times 3.16. Rounding to three significant digits, that's 15.3. And it would be in square feet. Area is always in square feet. Or square units. Feet in this case. All right, this one, we have a trapezoid, so area is going to be 1/2 times the height. The height is 9.71 times base 1, 14.9, plus base 2, 8.22. Okay, and I grab my calculator. 0.5 times 9.71 times 14.9 plus 8.22 is 112. Rounding to three significant digits. Square centimeters. I just put a square there, even though it ran off the edge of the camera. All right, find the perimeter and area of the cross section of a concrete highway support. So if you ever look at a bridge on the road, this is the general shape of the support that holds it up. So if we want to find the perimeter, basically we need to add everything up. So we need to go from here to here to there to there to there to there to there to there, all the way around. We do have two issues though. We know this distance. We know that one. We don't know this one right here. And therefore we don't know that one. But we know everything else. So I think what we have to do here is think of this little triangle right here, where this distance is 12, and this distance has to be 5, because that's 35 and that's 30. So we've got to use the Pythagorean theorem. Now I'm going to skip the Pythagorean theorem here because I happen to recognize something. This is a famous Pythagorean triple. This has to be 13. And if you don't believe me, go and check it. Do the Pythagorean theorem, 5 squared plus 12 squared, which means this one has to be 13 also. All right, so the perimeter is, starting at the bottom, we've got a 26. We've got a 30. We've got the 13. We've got 10. And then we've got all the way across is 50. Coming back down this way, another 10. Another 13. And another 30. Add those all up. 26 plus 30 plus 13 plus 10 plus 50 plus 10 plus 13 plus 30 is 182. And units here would be feet. The little hash mark there is feet. All right, now to find the area, I think there's a lot of ways you could do it. What I'm going to do is I'm going to draw a horizontal line here and another one here. So I'm thinking I've got this rectangle here, then I've got a trapezoid, and then I've got another rectangle. So my answer is going to be area is, starting with this one up on top, this is 10 by 50 plus, now the trapezoid is 1/2 times the height. The height would be this distance, which is 5, times base 1 is 26 plus base 2 is 50. And then finally this rectangle down at the bottom, that one's 26 by 30. I wrote it backward. I wrote 30 by 26. I don't know why. I just did. All right. 10 times 50 plus 1/2 times 5 times 26 plus 50 plus 30 times 26 is 1470 square feet. All right. Next page here. All right, next we have circles. So a circle, by definition, you have the center and then you have a radius. And the circle is all the points around the center the same distance from the radius. So we have our radius r, or we sometimes talk about diameter d. Diameter is the distance all the way across going through the center. All right, then there are two formulae that you need to know. The perimeter of a circle is traditionally called circumference. I don't know why the circumference for a circle gets a special name, but it does. And circumference is given by 2 pi r, which could also be given by 2d. I'm sorry, by pi d. Pi d. Because 2 radius is the same as a diameter. And then the area of a circle, the amount of stuff inside, is pi r squared. All right, so those are formulas that you need to sit down, you need to memorize. It's got to know. Okay, so 2 pulleys, each with a radius of 3 feet 2 inches, have their centers 11 feet 19 inches apart as shown below. What is the length of the belt needed for these pulleys? Express your final answer using feet and inches and round off to the nearest inch. Okay, well, what I think we need to do to work this out is first, let's convert everything to inches. So 3 feet 2 inches, that's 36 feet plus 2 is 38 inches. And then 11 feet 9 inches is, calculator here, 11 times 12 plus 9. That's 141 inches. So how long does the belt need to be? The belt needs to be 141 inches here, 141 inches there, and then it needs to be half a circle here and half a circle there, which means, of course, it's the full circle. And we're looking at around the outside, so we're looking at circumference. So what we need is 141 inches plus 141 inches plus 2 pi times the radius, which is 38 inches. I'll call that L for length. So that's 141 plus 141 plus 2 times pi times 38. Wake back up, computer. All right. So that's 520.76 inches. All right, so I'm going to divide that by 12. That's 43.3967 feet. But now I've got to convert. It said to give round off to the nearest inch. So I've got to convert 0.3967 into feet. So let's see, we subtract that 43 off. And then we multiply by 12. So it looks like it's 4.7 inches. So my answer is 43 feet, 5 inches. All right, now normally on a test, I probably wouldn't worry about you converting this back to feet and inches. If you just gave me the answer in inches or the answer in feet, it'd probably be fine. The converting back and forth is a little goofy. All right. Find the area and perimeter of the following figures. Okay, so what we have here, we have half a circle, and then we have a triangle. So it's given us the diameter. So let's see. Let's find the area first. I think we can find the area right off. So I got to take 18.5 and divide it by 2. So my radius is 9.25 feet. So the area is going to be pi r squared. That's the circle. Plus the area of the triangle is base times height. 18.5 times 15.5. I like the way that times looks. And of course times a half, 1/2 base height. Alright, so we got pi times 9.25 squared plus a half times 18.5 times 15.5. Rounding to 3 significant digits, we get 412 square feet. Now, to find the perimeter, I need to know the length of this side. So I need this side plus that side plus half of a circle. Oh, you know what? My answer's not right. I just realized my answer's not right here. Cross that off. Because we only have half a circle. I need to divide that part by 2. Alright, so I did second enter on my calculator. That pulls up the last thing I typed in. And then I can go here and I can tell it to insert, but divide by 2. Alright, so it should be 278 square feet. Ah, watch out for that. I missed that we had half a circle there. Alright, so this one, we have to do c squared is 9.25 squared plus 15.5 squared. So c is, grabbing my calculator, 9.25 squared plus 15.5 squared, and then take the square root of that. That's going to be 18.1. So my perimeter is going to be 18.1 plus 18.1. Same on both sides. Plus, I got to do half the circumference of a circle. So that's 1/2 times 2 pi r. All right. 18.1 times 2 plus, well, these reduce out. So I really just need pi times 9.25. So that's 65.3 feet, rounding to 3 significant digits. All right, going to have to pause and finish this sheet off with a second video.